Hey there everybody, it's Aubrey here. FPGAs, or field programmable gate arrays, are notoriously tricky to work with. Instead of being programmed through software, FPGAs are programmed through creating hardware architecture that will run algorithms, and this is all done with hardware level languages. While this makes them incredibly flexible for your use case, it also means they're pretty complex to get started with. Well, today we have the brand new MicroMod Sno processor board, which is a complete game changer for FPGAs because it makes it accessible through the Arduino IDE. This opens up the entire FPGA space to anyone and everyone who just knows Arduino. Besides the fact that this is now open for software programming, this Sno processor board has a small and compact MicroMod form factor, and it can boost the speed and performance of your project through FPGA acceleration and offloads. What do you say we take a closer look at everything this processor board can do? The Alorium Sno processor is equipped with the Intel Max 10 FPGA chip. It's programmable with the Arduino IDE and has embedded 8-bit AVR instruction set compatible microcontroller, which is compatible with the ATmega 328. It's configurable with a custom Accelerator Blocks on the FPGA, and it has a programmable interface through the USB serial. It has an operating voltage of 3.3 volts and a clock speed of 16 to 32 megahertz. Being a MicroMod processor board, it has a variety of digital I/O, including 32 dedicated digital pins, 6 shared digital with analog pins, 3.3 volt inputs, and 3.3 volt outputs. In terms of memory, it comes with a program flash of 32 kilobytes and a data memory SRAM of 2 kilobytes. There are also specific peripherals available on the MicroMod Alorium Sno M.2 processor, including a JTAG footprint for direct FPGA programming and the M.2 key interface for integration with all other MicroMod carrier boards. Let's get a little bit deeper into how this board works. The chip that makes up the Sno board has a substantial chunk of the FPGA dedicated to accelerator blocks. Accelerator blocks are an optimized hardware for a specific function, so you can think of them as libraries, except they are actual hardware configurations. Alorium technology provides a plethora of these, including servo control, quadrature, floating point math, NeoPixel, and enhanced analog to digital converter. And these are all accessible through the Arduino IDE like traditional Arduino libraries. Let's take a look at what this looks like in practice. FPGAs are ideal for situations that require speed and performance, and one good example of that is servos. Servo libraries use hardware timers and interrupts to drive signals, and since most AVR chips can only perform one interrupt at a time, it will cause the servo to glitch. Since the Sno board directly accesses the accelerate blocks, it doesn't run into the same jittering. We can actually run a traditional servo library on the Sno board and then switch it out for the accelerate servo library, and it will run the same code. So it's really as easy as including the accelerate specific library. Now, we'll run into more glitching when comparing this to a red board, but we can still see advantages of the Sno against other MicroMod processors when we begin to add on many servos. If you're bumping into issues in your project, then transitioning to the MicroMod Sno board is an easy way to use the same code but transfer functionality from software to hardware. FPGAs are able to accelerate specific functionalities that are too slow or even impossible for an 8-bit microcontroller. But they're also so complex that it's hard for an everyday engineer to just jump right in and get started. This new MicroMod Sno processor bridges that gap and enables all sorts of traditional Arduino-based projects to be run on an FPGA. And between documentation and project ideas at SparkFun and Alorium Technology, we're pretty certain that learning an FPGA with a Sno is about as simple as it gets. So head on over to sparkfun.com and pick up yours today to get started playing with FPGAs. Happy hacking! Just jump right into and get started with. That's why we need to redo this. That implements algorithms, okay, one more time. Too slow or even impossible for it to work through hardware level languages. I don't know what comes after that. I'm just completely blanking.